In this video, I'm going to construct the mother of all dimmers. And like with most of my projects, go to my website where you can download all the construction details and schematics and things like that. I made 3 different versions of this board. This is a low side board, this is a high side board, and this is a combination low side, high side. And if you don't know what those terms mean, then of course go to my website where I have tons of documentation on this project. About 95% of the components are the same in these 3 boards. It mostly just has to do with how they're connected. Now the first thing I want to mention is this combo board. Unfortunately, the problem is I had to use surface mount components on this to get everything to fit in this board profile. And here's an example of a surface mount component. This is a capacitor. And this is the equivalent capacitor in a through-hole component. That's actually the same component. One is a surface mount and one is a through-hole. Well, if you're a novice solderer, surface mount can be intimidating. And with my projects, I try to minimize surface mount as much as possible. And when I do, I try to use the largest ones that I can because that just makes it easier. So we're not going to demo this today, and just realize that it is available if you want. So we actually have left over a low side and high side version, and we're going to build the high side because it tends to be a little more popular than a low side. And so we'll take the low side out, and so this is the one we're going to build. And here is the parts that I've assembled for the board. And I tried to limit the number of suppliers as much as possible because otherwise you're spending more money in shipping. And so not a lot of parts, but there are a few. And the website shows a picture of this circuit board where all the little pieces go. So when I start soldering parts together, I like to use the smallest ones first because if you put the biggest ones in first, it's going to be hard to reach the smaller ones. So we're going to speed the camera up right now. And now I can tell the value of these resistors just by looking at them. But if you don't, I recommend buying something like this tester. And they're not that expensive. They're, with the case and everything, maybe $15. And you just put a component in here. And then it's going to tell you this is a 21.4 K ohm resistor. And actually it's marked as a 22K, but that's basically an acceptable tolerance. Now that we have the resistors on here, we want to put the remaining diodes on. And the diodes are polarity sensitive, and you'll see a white band on one end. On the board where the diode goes, you'll see an arrow pointing towards one hole, and that's where the white band goes. And you can get one of these little benders, and it allows you to put the component in the slot and then bend the leads like that. But I find it's just easiest to bend them by hand. I prefer these clear LEDs because they look nicer, but you can't tell what color they are, so we put it in a tester and that shows up as green. So we know that's a green LED. And I'm going to put the red LED here for the trigger, and these are polarity sensitive too. You'll see a short lead and a long lead. The short lead goes to the negative side or to the marked side. In this case, there's a little bit of silk screen here showing kind of like 2 little arrows going to the negative side. Now this is an opto-isolator, and you have to make sure that you get it oriented right. And there's normally an identifier, like a half moon here in this case. And this opto-isolator has a dot, and that dot always points towards the end with a mark. So I just tack one pin first, and then I push down on this side, and I usually can feel it going a little more like I did there. I usually like to go and alternate it like you would torquing down a tire, so we'll do the opposite corners. If you're a novice, what this basically does, it helps preventing heating one part of the component too much. And when you cut these leads off, be careful if you have a pair of cutters like this, because you can get really down flush, because you want to leave that dimple. Now when I put this fuse holder in, I want to put a fuse in here just at least part way to kind of help hold pins in place. you'll see that this has a tab on it on one end, and there's a thick line on the outline on one side. That tab goes to on the thick side. And then for the last component, we have our MOSFET, which actually does the dimming. Now you could solder these if you wanted to, but I'm not going to until we know for darn sure that this thing is working, because once you solder those on, it's almost impossible to get them off. No trick for PC board makers is I've left these traces copper, and if you run a bead of solder across them, you can increase the current handling capability because you're actually giving it more metal. And theoretically, that should give us 15 amps. And what we'll want to do now is test it. And so the next step is we have to program this ATtiny85. And this is simply just a clone of an Arduino Uno, and with a shield that plugs into the top of it that I built, and it allows you to program not only the ATtiny85 but other ATtiny microcontrollers. Now you don't have to use this shield. You can just, if you have a little breadboard, you can just wire it up. And if you don't know how to do this, I have another video that you can watch that shows you how to set this up. And when you're set up, we put in the ATtiny85 in here and then connect it to our computer. And once we've connected the computer to the programmer, we want to go to Tools, and we want to go to Board ATtiny. We want to make sure it shows ATtiny. Under Processor, we want to make sure it's ATtiny85. Under the clock, we want to make sure it says 8 megahertz internal. So then we go back to Tools, and we want to change this to Arduino as ISP, and the port will be different depending on, this is a Mac, and if you have a PC it'll have a COM port on it. So then what we want to do is make sure that we're on the right COM port, and then we want to click on Burn Bootloader, and we only need to do that once for every new chip that we use. Then we want to go to Sketch, Upload, and it's going to be again a little different on the PC, or we can click on the upload button here, and then it'll compile a sketch and eventually it'll upload it. And you see activity as it's uploading, and when that is done, you should get a done uploading confirmation on the Arduino IDE. And now all we have to do is unplug this, take the chip out. We want to make sure that we pay attention to where the dot is. And now we're ready to go. And I'm using this LED strip rather than a puck light because it's easier to see in the video. If I use a puck light, it's going to be too bright. On, dim, off, on, dim, off. And then we can adjust this to do the dimming. Now when I turn this override on, it goes into dim mode. And no matter what I do with this push button switch, it won't change. So you could have this override somewhere in the console. We're done with the rudimentary testing, so now we're going to put this into a potting box. Now this potting compound is actually designed for this purpose, for electronics, black epoxy, and it actually is going to encapsulate this into the box here. We're just going to start out with mixing some up. And quite frankly, this is probably the most expensive part of the project, is this encapsulating compound. It's probably cost more for this than it does for all the components combined. So let's just mix this up here. So I do like to pour a little bit in here to start with, and probably should be using gloves, but I'm not. And this stuff will find its own level, but what we don't want to do
is get this so high that it goes over, say, the socket and into the pins, because then you'll never get this off. And if you buy the components where I suggested, the bottoms should be sealed. Otherwise, this could seep up into the bottom. There we go.
And after letting the epoxy cure overnight, this is what we end up with. So now we're on to programming.
What we're looking at here is the source code for the dimmer, and it's called a sketch. I'm just going to kind of go over this really quickly and just give you an idea of the things that you can change if you wanted to. And by the way, anything that's marked with a double slash is a remark, and it's not part of the program. Here's a timer mode, 1, 2, and 3, and that little switch, that little red switch, you can make it a 0 or you can make it a 1, 2, or a 3. If it's a 0, then the timer mode is disabled. If it's a 1, the timer will shut the LED off after 1 hour. If it's a 2, it'll shut it off after 2 hours. If it's a 3, it'll shut it off after 4 hours. And it uses these values to determine that. Now, if you wanted to change that and make it 8 hours, you could replace, say, the 14.4 number with this 288 number up here, and then it would be 8 hours instead of 4 hours. So here's an example of how you can make a change in the code if you want to make the dimmer behave differently. The one thing I want to show you is this line here. This changes the LED output logarithmically when you change the dimmer to provide a more pleasing result. So it just makes it a little nicer. And if you want to change it to linear, this is the line that you would enable. You take the 2 dash marks off here and put 2 dash marks here, which would disable this line and then enable that line.